Assalamualaikum. For assignment 3, our team consists of 5 members. I am Nur Shazina Nur Hasrin together with Muhammad Daniel Rafiq, Nur Aliza Sharafina, Aimi Dania dan Nur Hayati. This video presents our assignment 3 for the learning factory, which focus on the conducting a time study and line balancing for the assembly of a USB fan. The process includes assembly, inspection and packaging with a target production capacity of 900 units per day. In this presentation, we will explain our analysis, workstation design and the application of the jigs and pokayuk to improve efficiency and quality. The purpose of this study is to have practical experience in applying industrial engineering concepts, specifically time study and line balancing in a real or simulated manufacturing environment. Next, we calculate the takt time. The takt time is the rate at which a product must be produced to meet the customer demand. The formula for the takt time is available production time divided to the customer demand. In our case, the available production time is 8 hours per day. Then, which is 8 hours per day, which is in second is 28,800 seconds. So the required production output is 900 production output, which is the takt time is 28,800 divided by 900 and equals to 32 seconds per unit. This means one USB fan must be complete every 32 seconds to meet the daily demand.
Hi, for the next part, we conducted a time study to measure the actual time taken for each work element in the USB fan assembly process. The time study was conducted by observing 10 cycles for each process to obtain accurate average time. The assembly process was divided into the following work element, which is preparing of components, motor and blade assembly, cover, installation and screw fastening, inspection and also packaging. For each work element, the observed time were recorded and the average time was calculated. Based on our time study, the total process time for one USB fan is 153.3 seconds, which is included assembly, inspection and packaging. Sweep or standard work in process represent the number of units that should be in the system to maintain a smooth production flow. The formula for sweep is sweep equal to total process time divided by takt time. Substituting our value, which is 153.3 divided by 32 equal to 4.79, which is rounded up to 5 units. Similarly, the minimum number of workstation required is calculated using the same values. Therefore, a minimum of 5 workstations is required to meet the production demand.
For this section, I will explain the precedence diagram and line balancing for the USB fan assembly process based on the time study data. The assembly process starts with picking up all fan components followed by assembling the fan body or motor. Next, the fan blade is installed, followed by the installation of the fan guard. After that, the left and also right stands are assembled. Once the assembly is completed, inspection is carried out, and finally the product is packaged. This sequence is illustrated in the precedence diagram, which shows the required order of tasks from start to finish. Based on the time study results, the total process time for the USB fan assembly is 159.3 seconds, which is approximately 160 seconds. So, in this study, the takt time is set at 32 seconds. The minimum number of workstations is calculated by dividing the total process time by the takt time. Therefore, 159.3 seconds divided by 32 seconds gives us the 4.98, which is rounded up to 5 workstations. After determining the number of workstations, the tasks are allocated according to the precedence constraints and takt time. At workstation 1, the tasks include picking up fan components and installing the blade, with a total time of 31.9 seconds. For workstation 2 is assigned to assemble the fan body or motor with a total time of 28.9 seconds. At workstation 3, installing the fan guard and packaging are combined, with a total time of 35.8 seconds. Workstation 4 is responsible for installing the left stand with a total time of 24.6 seconds. And finally, workstation 5 includes installing the right stand and conducting inspection with a total time of 38.1 seconds. As for the conclusion, the production line is considered balanced as the tasks are distributed across 5 workstations based on the takt time and precedence requirements. This arrangement helps to reduce bottlenecks and ensure a smoother assembly flow.
So I will continue about the Pokayo Engine demonstration. Now I will demonstrate the Pokayo Engine system used in the mini fan assembly. As you can see, this jig is used to hold the component in the correct position during assembly. When the motor and casing are placed into the jig, they fit only in one correct orientation. By using this jig, errors are prevented at the source rather than corrected later. This reduces rework, improve product quality, and also ensure a consistent and efficient assembly process for the mini fan.
To conclude, our team has successfully analyzed the USB fan assembly line using key industrial engineering tools such as takt time calculation, time study, SWIP, and line balancing. By arranging the tasks based on the precedent diagram, we were able to design a smoother and more efficient production flow. This helped us reduce idle time, avoid bottleneck, and improve overall productivity. With the final line setup, our assembly system is now capable of achieving the required daily output of 900 units per day, which meets the production target. Overall, this project shows how important proper planning, teamwork, and line balancing are in creating an efficient and workable manufacturing system. Thank you.